Up in lesson 3.5 for day 2. Remember, there is going to be a day 3. I will tell you that Savvas will be popping available during this period. So you will have the availability to get into Savvas and start working on it. However, let's work on getting through some notes. So yesterday we were talking about 3.5. We were talking about finding the zeros. So we had to do some factoring to find zeros in some of the problems, right? And then we talked about looking at where is it above, where is it below the x-axis, and then sketching a graph, okay? So now we're going to talk about different zeros, and we're going to talk about something called multiplicity. Multiplicity is the multiplicity of a zero of a polynomial function is the number of times the related linear factor is repeated in the factor form. Multiplicity of a zero is determined by the power of the linear factor. So basically, when you have a zero, okay, it starts off as a factor. How many times that factor is part of the problem? So basically the power on it. That determines what happens at that point on the graph, okay? And so basically the power of the factor is your multiplicity. And then what we're going to be looking at is when the power of that factor, or the multiplicity, is odd, the graph is still going to cross the x-axis, just like what we're used to when we talk about a zero, how the graph just crosses through that value. However, the other option we're going to consider is when the multiplicity is even. So when you have a power on a factor and it's even, if that's the case, instead of crossing through the x-axis, our graph is simply going to touch the x-axis. So basically it touches the x-axis and then turns and goes away from the x-axis. It never actually crosses through it. So this is something called multiplicity. Multiplicity helps us to describe the behavior of the graph at its zeros. And that's what we're being asked to do here. So let's look at this example. Officially, it's described the behavior of the graph at each of its zeros. So we're going to name its zeros. And ultimately, we need to say, okay, at this zero, does the graph cross or touch the x-axis? At this zero, does it cross or touch the x-axis? That's our ultimate goal. Let's start with the zeros. How do I find the zeros? Okay, set equal to 0, and we can kind of speed it up by setting each factor equal to 0. Now, what's the first factor I'm going to set equal to 0? We're going to set x equal to 0. I'm going to kind of spread these out so I have some room to work. We're also going to set x plus 4 equal to 0 and x minus 1 equal to 0, yes? We're going to find our zeros. The first zero I'm going to have is x equals 0. What about when it's x plus 4? Subtract 4, and x equals negative 4. And when it's x minus 1, add 1, and it's x equals 1. What are those three numbers that I have listed there? Those are my zeros. Okay, so right now I have zeros of 0, negative 4, and 1. Now, the next thing we're going to talk about is we're going to talk about the multiplicity of each of these zeros. When I'm talking about multiplicity, I want to know what's the power on that factor. Let me start actually over here at 1. The 0 of x equal 1. It came from the factor x minus 1, yes? What's the power on that factor? Are you guys with them? Mm-hmm. There is a power of 4 on the factor of x minus 1. That means the multiplicity here is 4. I'm just going to write it as an m so we have something to know what that number is. But that's a multiplicity of 4. We'll circle back here in a moment and talk about what that means. What about when my 0 is negative 4? That came from the factor x plus 4. What's my power?
4. Right? Where's it 1?
On x plus 4, what was the power of the factor?
1.
There is an invisible 1 there, yes? There's an invisible 1, so that means my multiplicity is 1. Same thing for x, or for 0. X equals 0. What was the power on that factor? What's the power on x here?
1.
Invisible 1 again, yes? So it also has a multiplicity of 1. Those are the multiplicities. Now, they help us figure out what's going on with my graph at that point. What do we know about the number 1? Is it even or odd?
Odd.
Agreed? Okay. So since 1 is odd, what does it say? When the multiplicity is odd, what's my graph going to do? It's going to cross the x-axis. So what I know, because this multiplicity is odd, is that my graph is going to cross the x-axis at, what is the 0 here? And that is x equals 0. Okay? So because the multiplicity is odd, my graph is just going to cross through the x-axis there. What about the next multiplicity? What do you know about the multiplicity of 1 again? Well, 1 didn't change. What do we know about 1? It is still odd. So what is my graph going to do at this 0? It's also going to what? Cross. So my graph is going to cross the x-axis, and this time we're talking at the 0, x equals -4. And what do you know about the multiplicity of 4? 4 is even, yes? 4 is an even number. What does it say is going to happen when the multiplicity is even? Okay, it's going to touch the x-axis. So it's not actually going to cross through the x-axis here. So what I can say is that here my graph is going to touch the x-axis. And in this case, we're talking at x equals 1. Okay? And that's because we have an even multiplicity. Okay?
Sorry.
Oh, you're right. So, when you guys are talking answers here, we're looking at that whole section here. Identifying each of your zeros, what the multiplicity is, which then leads to what's the behavior. Is it crossing the x-axis or touching the x-axis? And I'll look at a sketch and show you exactly what we mean here. Did you need something from me?
Signature for your contract.
Did I not sign this, or is this?
This is the new one from the negotiation.
Oh.
And this will be in the next paycheck.
The very next day? Like this Friday, or?
She said. Like you'll get your back pay in this, what she said.
I thought we had another. Oh wait, no, it went through the last board meeting, didn't it?
Yeah.
Okay. Okay. Nice.
Christmas money.
I just wasn't expecting it quite so soon, but bad news about the washing machine today, so I'll take it.
Wait, isn't the washing machine the one where you put the dishes in? Or is that the dishwasher? Oh, that's the dishwasher. I don't clean my clothes, so
Silly goose.
my parents do.
Maybe you should take home ec.
What is that?
Facts, fix it,
Okay.
We're in there with me.
I thought that was the washer. Like the washer? Like,
Washing machine is what gives you clean clothes. You might want to,
sure.
sometime in the next
My mom
couple of
always
years.
does my clothes.
Okay, sometime in the next couple of years,
Learn the
you might want to learn the washing machine.
Maybe.
Now,
My mom.
I can say guilty. My kids don't necessarily know how to really use the washing machine much either, so, you know, but. Okay, now, real quick, let's talk about the graph here. I'm just doing a quick little sketch. And notice, this sketch isn't something that was stated in the directions, right? This sketch is just trying to help you guys understand what this graph would look like. We had zeros at what? 0, -4, and 1, right? So I know my graph has to touch or cross at each of those points. Okay? Now, based on the fact, this is me knowing this, not necessarily you, if I were to multiply all this out together, I also know that I'm going to have a power, if I add all these x's up, 4, 5, 6, and a power of x to the 6th is even. So I also know that my end behavior is going to be up and up. Now again, I'm not expecting you guys to know that, okay? I'm just trying to explain my reasoning. So if I'm starting up, and then what am I supposed to be doing at -4? At -4, it says I'm going to cross the x-axis. So I'm going to cross through it. I'm going to keep going. And then at 0, when I get over to 0, I'm also supposed to be crossing it, yes?
Mm-hmm.
But what am I supposed to be doing at 1? At 1, I'm supposed to be touching the x-axis. So notice, did I cross through? No, I touched it and turned back up. So that's the idea. What I wanted you guys to see, because I'm using the vocabulary words cross versus touch. Did you really truly understand what they mean? Maybe, maybe not. Okay, I want you guys to see, like, okay, that's a cross. That's a cross. There's what a touch is. Okay? So this is what we're doing, is we're describing, okay, my graph is going to cross through the x-axis or touch the x-axis. Okay? Questions on that? Okay, let's see if we can figure out the next one. We're going to go through, identify the zeros, and talk about what they do at the x-axis. So, how am I going to start by finding the zeros? Okay, we're going to set each factor equal to 0. So we're going to set x squared plus 9 equal to 0. I'm going to set x minus 1 equal to 0. And I'm going to set x plus 2 equal to 0. Let's find our zeros. What happens when we do x squared plus 9 equal to 0? No. So how do we solve?
Oh wait, it's you subtract the 9 over.
Subtract the 9 over. Remember, you're trying to solve for x. So officially you have x squared equals -9.
And then you have to take the square root of both.
And then officially you have to take the square root.
Oh, it's gonna be like that. I.
Plus or minus 9
Okay.
or 3i.
The square root of 9 is 3. When we talk about the square root of a negative, remember that's when we put in an I. And then when you take a square root in equation setting, we say plus or minus. Okay, so we have 2 zeros there. Plus 3i, negative 3i. We'll come back to that here in a moment. What are my other zeros? X minus 1 equals 0. What's that 0? X equals 1. And if we have x plus 2 equals 0, what's that? X equals -2. So what did I just list? I listed my zeros, yes? Okay. Now, let's talk multiplicity. Plus or minus 3i. Am I going to see those? They're imaginary, right? Am I going to physically see those on the graph? No, because they're imaginary. So, are we going to worry about whether they touch or cross the x-axis? No. Is there a multiplicity to worry about then? No.
So we
Okay.
like when they're like that.
Okay, so with these two, basically, these two don't matter with what we're doing because they are not real. Okay, so basically, yes, they're zeros, but they're not real. So I'm not going to worry about whether they, trying to figure out if it crosses or touches there. Does that make sense? Okay, They're not real. Basically, I'm saying ignore, move on, next one. Okay, what about 1? X equals 1. What's my multiplicity?
1.
5, because what's the power on the factor? X equals 1 comes from x minus 1. It had a power of 5. What's the multiplicity on x equals negative 2?
2.
The factor of x plus 2 has a power of 2, so has a multiplicity of 2. Okay. What about the multiplicity of 5? What do you know about the number 5?
It's odd.
It's odd. What does an odd multiplicity tell me?
It crosses the x-axis. Yeah.
Okay. When there's an odd multiplicity, it's going to cross the x-axis. So my graph is going to cross the x-axis at x equals 1. Odd multiplicities tell me to cross. What's the multiplicity on x equals negative 2? It's 2. What do we know about the multiplicity of 2?
Even.
Multiplicity of 2 is even, which means my graph is going to just touch the x-axis at the 0, x equals negative 2. Okay? Your answers here are the real zeros, 1 and negative 2. Their multiplicities of 5 and 2, and the fact that they cross and touch the x-axis, respectively. Okay? Might they ask you about the complex zeros, the not real zeros? They could, but I don't know that they will. Or at least not in that scenario. Does that make sense? Okay. Moving on? Okay. On the back side. Oh, I said moving on. I didn't sketch a graph for you.
Yeah.
I want to sketch a graph. I don't know if you guys care about the graph, but I want to sketch the graph. How's that? You guys may care nothing about the graph, but I want you to see it. Okay, what were my real zeros? We have a 0 at 1.
And negative 2.
And negative 2. So I know somehow or another my graph connects with those points, yes? Now, I also know if I add up my x's, I have x to the second, x to the fifth, and I have an x to the second there. 5 plus 2 plus 2 is going to be x to the ninth. I know 9 is odd, yes? So an x to the ninth, which is odd, means I'm going to have down and up in behavior. Okay? Now, so let's look. I'm going to start down. And as I approach negative 2, what am I doing at negative 2? I'm going to touch. So as I touch negative 2, I'm going to touch it and go back down. Then I'm going to work my way over to 1. And at 1, I'm supposed to cross, yes? Now, I will say at 1, when you do that cross, it's going to flatten out a little bit because it's a higher multiplicity. So it's going to kind of do like a zigzag, like a little cross. But it's still going to have the same idea. Okay? And again, I'm just trying to get you to help visualize these graphs. Finding, crossing, and touching information is grand, but what's it really look like? Okay. Now, if we move to the back page, you guys are like, hey, I'd already moved to back page, Mr. Sargent. You took us back. Okay, true. Okay. On the back side, we're going to spend some time finding zeros. They're asking us to find, notice what it says here, all of the real and the complex zeros. Now, we know what real is. What's complex? When they say complex, that's their fancy way of saying imaginary zeros. So those are the zeros that are in the form a plus bi. Okay. So we're going to find the real, we're going to find the imaginary. As you look at A, they give us an equation and they give us a graph, yes? These are one and the same, they go together. This graph represents this equation. Now, as you look at the graph, what do you see? What do you see that's important here? It does. Where's it? It crosses the x-axis. Where's it cross the x-axis? At 2. So far, we have found how many zeros? 1. Now, officially, I'm going to ask you how many total zeros are there supposed to be. Think of it this way. How many, if we were solving this equation, how many answers are there supposed to be? What's the highest power?
3.
The highest power is 3. The fact that the highest power is 3 tells me that there are 3 answers to this problem. Just like when we solved x squared equations, how many answers did you expect to find? 2, right? When you solve an x to the third equation, expect to find 3. If you solve an x to the fourth equation, guess what? You're going to expect to find 4. Well, so x to the third, we expect to find 3 answers. What do we see right now? We see 1. What's that mean about the other 2, probably? They're both imaginary. They fall into those complex numbers. Okay, so our job is to find all of them. So I'm going to start off by stating, what is the first answer we found? We found there to be a 0 at x equals 2, correct? That is one of your answers. Is it my only answer? No, I got 2 more. Okay, and for reference, also keep in mind, a 0 of x equal 2, what does it look like as a factor? In other words, if you put x equals 2 in parentheses, it comes from the factor what? X minus 2, right? So I just want you to realize that a 0 at x equals 2 is the factor x minus 2. Okay? Now, we are going to divide. However, Emily's starting to freak out on me. What kind of division am I going to do?
Long.
Synthetic.
Synthetic.
Oh.
Forget the long division. We're going to do synthetic. Okay, we're going to use synthetic
I like long.
to divide this 2 out and find our other factors. So, in the box, it is going the 2. What goes next to this 2?
1. Negative 3 and negative 6.
Okay, are you guys with them? Coefficients, 1, 1, negative 3, negative 6. Now, folks, I do still have more work to do. I am leaving a section open over here on purpose. So don't totally fill this space up. I still have work to do, FYI. Okay, do you guys remember your synthetic division? Drop the 1. 2 times 1 is?
2.
2. Add. 1 plus 2 is?
3.
3. Now what?
3 times 2.
Multiply. 2 times 3 is? 6. Add. Negative 3 plus 6 is? 3. Multiply. 2 times 3 is? 6. Add. Negative 6 plus 6?
0.
0. What just happened?
R0.
We got a remainder of 0. Is that what I needed to happen?
Yes.
Yeah. That just verifies, as the graph shows, that 2 is indeed one of my answers. Now, where are the rest of my answers? They're in there. What does that 1, 3, 3 represent?
The other factor.
Yeah. But specifically, if I put my variables back in here.
X squared minus 3x plus 3, x squared plus 3x plus 3.
There we go. So 133, not to be mistaken for 133, which I got this morning, okay, is x squared plus 3x plus 3. Yes? And then the other factor, what's the other factor we have? Well, 2 represents the factor x minus 2, right? So we know what that is. What we don't know is what the answers are to x squared plus 3x plus 3. Well, that would be nice. So let's look at our options here. I'm going to take this factor of x squared plus 3x plus 3 and set equal to 0. The question was, do we need to factor it? I would love to factor it. But keep in mind, what kind of answers are going to come out of this? My imaginary answers. Does this factor? I wish it did. Okay. And I'm not saying it couldn't, but in this particular situation, I can't, there aren't two numbers that multiply to be 3 and add to be 3. That just doesn't happen. So, what's another plan to solve when factoring fails?
Quadratic.
Quadratic what?
Formula.
Quadratic formula?
Nothing.
Oh, yeah.
Back in topic 2 on our blue paper, did we have something called a quadratic formula that we used when factoring failed?
Yeah.
Guess what?
It's back.
It's back. It never really left,
Nothing.
but it's back.
Back on the corner.
Okay. Now, I'm not going to leave it here, but I'm just going to write it up here so I have it for this particular problem. Negative b plus or minus the square root.
B squared minus 4ac on top of 2a.
Okay. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Helpful to know that. Okay, and again, I'm just putting it up here so you have it. I don't know if I'll have room to leave it there later. I might need that room, you know. But you could probably put it right in this area and you would have room. Okay, guys, so let's go. Negative b. What is b?
3.
3. So negative b is negative 3 plus or minus the square root b squared. What is b? 3 squared minus 4 times a, which is 1, times c, which is 3, all over 2a, 2 times 1. Okay. Clean up. Negative 3 is negative 3. Plus or minus. Okay, that square root. 3 squared is 9. 4 times 1 times 3. 12. 9 minus 12. Negative 3. Are you guys with me if I say there's negative 3 under the square root? All over 2. Okay. One more cleanup step. Negative 3 plus or minus. You guys remember that? And again, I'm definitely going to erase this. Square root of negative 3 is square root of negative 1 times square root of 3. Square root of negative 1 is I. What about square root of 3? I don't know it, so I leave it like that. Sound familiar? Taught it this year. Hasn't been that long ago, but. So I square roots of 3 all over 2. Well, that does not reduce. Guess what?
What?
That's part of my answers.
Oh, I don't like it.
Okay. How many answers is that?
2.
Plus or minus represents 2 answers. What had I already found?
The one right there.
Didn't we already have x equals 2? How many total answers do I have now? 3. How many was I looking for? 3. I'm done. Okay. Questions I should answer here.
Will Savas get mad at us if it asks for 3 answers and we put plus minus?
I don't know. I wish I had a better answer for that, but I don't know. Savas should not get mad at you for plus or minus. And I feel like most of the time they don't. But I know on occasion you guys have told me there are occasions where they don't approve of plus or minus. I don't see why they wouldn't, though. Okay. Ready for B? Let's try B. Okay. I'm rewriting my quadratic formula right here. Because I think if I put it in right here, I have room for it. Which, by the way, I didn't put up here, but quadratic formula. It's based on the format of what? AX squared plus BX plus C officially equals 0, yes? Okay, so side note there. Okay, what do you see on B? What's my graph do?
Crosses at 3.
It crosses at 3. So what do I know? One of my answers is 3. I know there is a 0 at x equals 3. I know when I get to the end of this problem, one of my answers is x equals 3. How many more answers am I looking for?
2.
2 more, because how many total answers are there in this problem?
3.
It was x to the third, which means 3 total answers. If I physically see 1, and that's all I see, what's that mean about the other 2? They're imaginary, yes? So similar setup to what we did last time? Okay, so this is 0 at x equals 3. Remember, it is represented as a factor of x minus 3. We're going to set up some synthetic division because we've got to divide out this 3 here. So put the 3 in the box. What goes beside the box?
2, -8, 9, -9.
Okay. And we're going to carry the 2 down. 3 times 2 is, whoops. Carry the 2 down and actually write it down. Most of you aren't watching me, that's good. 3 times 2 is 6. -8 plus 6? -2.
2, yeah.
3 times -2? -6. 9 plus -6? 3. 3 times 3? 9 plus 9?
Lose egg. 0.
Okay. We expected that 0, didn't we? That remainder tells me I didn't make any mistakes. It tells me 3 works as it looks like it should in the graph. So, what does that 2, -2, 3 represent?
2x squared minus 2x plus 3.
Okay. That's one of our factors. Officially, our other factor is the 3, which is x minus 3. Not that we really need that right now, but that's kind of where we're at. Okay, what are we going to do? Take this one factor, 2x squared minus 2x plus 3, set it equal to 0. Realize you're wasting your time trying to factor this. Is it going to factor? No, because I'm looking for some imaginary answers here. It's not going to factor. So we're going to jump straight to, we already did synthetic division. Quadratic formula. So, x equals -b. Well, if b is -2, when I say -b, we're going to put in
2.
+2. Plus or minus the square root b squared So negative 2 squared minus 4 times a, which is 2, times c, which is 3, all over
2.
2a. So 2 times 2. Keep going. 2 plus or minus. Okay, guys. What is negative 2 squared?
4.
When you square a negative, you get positive 4. And then we're going to subtract whatever 4 times 2 times 3 is. Well, 4 times 2 is 8. Times 3 is 24. What's 4 minus 24? Negative 20. All over
4.
2 times 2, which is 4. Okay. Keep going. 2 plus or minus. Okay, guys. Square root of negative 20. What do you remember?
Negative 1.
20.
And it's 4.
4, 5.
Does that sound familiar, guys? Why didn't I just do negative 1 and 20? 20 has a
Square.
perfect square in it, right?
Mhm.
So the negative 1 becomes an I. The square root of 4 becomes a
Those.
2. And the square root of 5 is a square root of 5. So put that together and it's 2i square root of 5
Over 4.
all over
4.
4.
Yeah.
You didn't see that.
I didn't.
Now, Savas is going to want you to go one more step. 2, 4, and 2. All divide by 2. Now, on this last one, I left it as one big fraction. In my notes, I'll be honest, I have it as 2 fractions. What will Savas expect? I don't know. So what I'm saying here is 2 over 4 and 2 over 4 both reduce to 1/2. So you might need to say 1 over 2 plus or minus I square root of 5 over 2. You realize what happened there, right? 2/4 becomes 1/2 in both cases.
Would you tip the other one though, as an answer on the test? Or
I would, definitely.
Alright.
And Savas might. Could you have possibly left that together as 1 plus or minus I square root of 5 all over 2? Possibly. Now, okay, what do you need to give in terms of answers here for full credit? What are all real and complex zeros?
X equals 3.
And x equals 3. Right? So there's 1, 2 with the plus minus, and then there's the 3. Don't forget that. Okay, tomorrow we will look at C and we will look at the bottom 2. I don't know, maybe some work time tomorrow. I would love to think that, but we've been going slow the last couple of days, so who knows?